This is definitive, the most comprehensive, deep dive exposé on the truth behind 3I Atlas. In just 4 short months, scientists have already published nearly 100 research papers on this object. Furthermore, there is a massive amount of bizarre internet rumors swirling around. Today, we're clearing the fog to show you what's actually going on. Bookmark this and listen closely. Actually, humanity has been tracking 3I Atlas since July 20th. 2025, it was formally discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS. This system is essentially a global array of telescopes located in places like Hawaii, Chile, and South Africa. Their job is to stare at the night sky, hunting for moving celestial bodies. On the night of July 1st, ATLAS spotted a moving object and initially categorized it as a new asteroid. But soon after, ATLAS noticed something strange. The object's movement speed was simply too high. When ATLAS calculated the velocity of this new asteroid, astronomers were shocked. It turned out to be the fastest moving object ever detected within our solar system. To understand just how fast, let's establish some concepts. Earth orbits the Sun at about 30 kilometers per second, roughly 67.000 miles per hour. Earth moves quite fast because it's relatively close to the Sun and needs that orbital speed to counteract the Sun's gravitational pull. Planets even closer, like Mercury, 0.40 from the surface, must orbit at about 48 kilometers per second to avoid falling in. But this new object discovered by ATLAS? Its speed was a staggering 58 kilometers per second, and at that time, it was still far inside Jupiter's orbit, at a distance of about 4.5 astronomical units, from the Sun. At such high velocity, it was obvious this object would follow a hyperbolic trajectory, cruising past the Sun and ejecting right out of the solar system. Visitor 3I Atlas, originating from interstellar space, will finish its tour of our system and return to the cosmos. So, where does the name 3I Atlas come from? 3I represents the third interstellar object ever discovered by humans intruding into our solar system. Before it, there were 2 others, the first confirmed interstellar visitor ever, Oumuamua, and the second confirmed one, 2I Borisov. There are 3 major differences between 3I Atlas and the others. First is size. 3I Atlas is much larger. Oumuamua was up to 400 meters wide, and 2I Borisov about 1 kilometer. But 3I Atlas is likely up to 5.6 kilometers wide. Second is speed. 3I Atlas is traveling at roughly twice the speed of Oumuamua. The third difference, the direction it came from, is probably the weirdest part. Oumuamua essentially came from the front, the northern sky of the solar system, which is roughly the direction our solar system is moving through space. So, in a way, we sort of ran into Oumuamua. 2I Borisov was similar. It entered at a steeper angle but still from roughly the same general direction. However, 3I Atlas came from the side. It is almost perfectly aligned with the orbital plane of all the planets. You have to remember, the early solar system was a disk of material gradually forming around the Sun. All this material constantly collided, eventually forming planets and asteroids, so they generally remain on that relatively flat ecliptic plane. Only a few objects deviate slightly. Pluto's orbit, for instance, is tilted about 17 degrees, so sometimes it's above the plane, sometimes below. Now look at how coincidentally aligned 3I Atlas is. This interstellar object deviates from the ecliptic plane by only about 3 degrees, crashing into the solar system almost perfectly along that plane. Knowing that interstellar space is 3-dimensional, and this object could have come from any direction, hitting the solar system almost perfectly, edge-on, is an absolutely stunning coincidence. This also leads to a bigger question. Where exactly did 3I Atlas come from? If we look at the Milky Way from above, you see Earth here, in a spiral arm on the outskirts. Specifically, Atlas likely came from the direction to the right of the galactic core, an area packed with stars, much denser than Earth's neighborhood. Like the solar system, most matter in the Milky Way is concentrated in a thin disk around the core. But some objects are scattered above and below this disk. This is called the thick disk, or rear disk. Objects here are much sparser, so you rarely see violent supernovae explosions. Objects in this region tend to exist undisturbed for incredibly long periods of time. Astronomers believe 3I ATLAS comes from this ancient region of space, potentially making it up to 7.6 billion years old, nearly twice the age of Earth. While humanity may never accurately trace 3I Atlas's specific origin point, astronomers recently successfully backtracked its path over 10 million years and identified 93 stars that it encountered during that time. Incredible as it seems, over that 10 million year journey, the closest distance 3I ATLAS ever got to any star was probably a distant 0.2 light years. Yet right now, it is only 1.4 astronomical units from our Sun. So why is 3I ATLAS getting so close to the Sun? It was actually first observed back on May 7, 2025, appearing in images captured by TESS. TESS is an Earth-orbiting observatory designed to deep survey the Milky Way and identify new planets in other star systems. For about a month, TESS just happened to be pointed right in 3I Atlas's direction. This gave humanity a chance to track it as it crossed Jupiter's orbit. During the month TESS observed it, 3I ATLAS moved about 1 astronomical unit toward the Sun. So astronomers expected it to brighten. They predicted its visual brightness would increase about 1.5 times between May and June. But TESS data showed its actual brightness increased 5-fold. The light reflected by 3I ATLAS increased massively compared to expectations. This is why astronomers determined it wasn't an asteroid, but a comet. It was the coma, the surrounding cloud of gas and dust, reflecting the extra light. However, there were 2 strange things about this observation. The first involves polarization, when light from the Sun hits the gas and dust cloud around 3I Atlas. The light scatters in different directions, but the direction the light bounces isn't random. The angle of scattered light tells astronomers a lot about the object it hit. If light scatters sideways perpendicularly, it's called positive polarization. If it bounces straight back parallel, it's called negative polarization. Most objects in space have moderate positive polarization. Even the interstellar object 2I Borisov had slight positive polarization. But 3I ATLAS just had to be negative. Not only that, it possesses the most extreme negative polarization of any object ever discovered. Secondly, the surprising thing about 3I Atlas's coma was how early it appeared. Remember, during that May to June observation period, it was still far beyond Jupiter's orbit, over 5 astronomical units from the Sun. The environment there is intensely cold. Theoretically, 3I ATLAS shouldn't have been observable then because it usually wouldn't have started forming a coma. Volatile materials remain solid. Usually, the cometary sublimation process only truly begins between 3 and 4 astronomical units. As humanity continued observing, astronomers learned that its coma was actually dominated by carbon dioxide gas. It did contain some water vapor, but the proportion of CO2 was much higher, a ratio of about 8-to-1, which is totally different from what we usually find in comets. Imagine dry ice. Once taken out of a frozen environment, it immediately starts sublimating, creating that iconic cloud of gas. That is perhaps exactly the process 3I ATLAS was undergoing. Carbon dioxide ice sublimes at a much lower temperature than water ice, which is precisely why its coma formed so early. The weirdness gets even deeper, as astronomers kept watching 3I ATLAS approach the Sun. Its CO2 to water ratio began to flip. By the second half of September, as it crossed Mars' orbit about 1.5 astronomical units from the Sun, 3I ATLAS actually started releasing massive amounts of water vapor, way more than astronomers expected. The same situation occurred with metal substances in its coma. When observed in the summer, astronomers detected a small amount of nickel in the surrounding cloud, but no iron. You have to know that nickel and iron form inside the cores of dying stars. They share the same origin and usually appear together in asteroids and comets. So when astronomers saw plenty of nickel but no iron in 3I Atlas, we really wanted to know where the iron went. What process separated them? Just like water vapor suddenly appeared in the coma, iron eventually did the same. By late September, astronomers detected the presence of iron in the coma for the first time. And then the nickel-to-iron ratio very rapidly shifted to a more normal proportion. What on earth caused this? It's a real headache. Next, let's look at 3I Atlas's tail. This is a major area where its behavior differs from a typical comet. When astronomers first saw the tail forming in the summer, It seemed to be pointing in the wrong direction. It had a sunward-facing tail. Comet tails are generally considered the result of the interaction between solar wind and the coma. The solar wind blows away from the sun, so we expect the tail to drift away from the sun. Yet, the reality was the exact opposite. Astronomers speculate this might be related to the early stages of its coma formation. Early on, due to high CO2 concentration, 3I ATLAS started outgassing very far from the sun. It's possible the solar wind intensity back then wasn't strong enough to blow the gas and dust cloud away. So the tail was more like material just being heated by sunlight. It wasn't until it encountered sufficiently strong solar wind that it finally formed a tail pointing away from the sun, which is exactly the state 3I ATLAS eventually exhibited in September. By now, you must be wondering, does humanity have a chance to observe 3I ATLAS up close? Currently, 3I Atlas is entering its perihelion, its closest point to the Sun, estimated for October 29th. At that time, it will be about 1.4 astronomical units from the Sun. So, it actually won't get too close to the Sun. Its position will be roughly inside Mars' orbit. Therefore, astronomers discovered that the best observation opportunities will come from Mars. In October, 3I ATLAS will skim past Mars at a distance of 0.19 astronomical units. This is its closest encounter with any body in the solar system. Fortunately, humans have many space cameras located on and around Mars. When the time comes, we can use these eyes installed on the red planet to get a close look at the mysterious 3I Atlas. For example, right here is a photo captured from the surface of Mars by a Mars rover. This is what 3I ATLAS looks like in the night sky. It's not a very clear photo because the rover's camera wasn't specifically designed for this task. To capture this much light, the camera had to perform a 30-second long exposure and stack several images together. So, you end up with something looking more like a streak than a sharply defined comet. Next, here's another image captured by an ESA probe. It looks clearer, but still lacks enough resolution to distinguish the coma from the comet nucleus itself. To get more detail, NASA's Mars Reconnaissance Orbiter, MRO, as the most powerful telescope in the Martian system, might be able to capture clearer photos. To summarize 3I Atlas in 2 sentences, for an interstellar object, if it didn't have some strangeness, it wouldn't be fit to be called an interstellar object. As details increase over time, the rumors will naturally decrease. See you next time.